Howdy everyone, Dr. Regev here. Today I'll be reviewing a recent paper from May 28th, 2025, titled MultiFormer, a person pose estimation system based on CSI and attention mechanism. The authors propose a novel, wireless-based, human pose estimation system using Wi-Fi Channel State Information, or CSI, and a transformer-based architecture. The motivation here is to replace a camera-based system with a non-intrusive and privacy-preserving and low-light capable algorithm for human pose estimation. However, CSI is not like an image. It's a high-dimensional time-frequency tensor or signal, and most prior methods, as they state here, are treating it as if it's an image using CNN or PAM, which is pose adjacency matrix regression. These approaches struggle, especially in multi-person scenarios and for high mobility key points like wrists and elbows. So here the authors start to cover what they propose and what are their main innovations, which are three innovations. One is time-frequency dual-dimensional tokenization, TFDDT, to convert a raw CSI into sequences of frequency and temporal tokens, preserving structure along both axes. Two, a dual-branch transformer encoder that extracts features using multi-head self-attention, modeling spectral and temporal dependency. And three, right here, a multi-stage feature fusion network, MSFN, with PCM and PAF heatmap decoding, refining pose estimates iteratively using attention mechanism. So here they basically deep dive into the architecture. They start by taking raw CSI data from three receivers at 50 Hertz and upsample it using a sync kernel along both time and frequency. And two tokens vectors are created, frequency tokens and temporal tokens. Each token is 1296 in dimension. And the transformer processes these in two separate attention pathways, as seen in these images. The multi-head attention details. Each branch has a multi-head attention followed by a multi-layer perceptron and a convolution reconstruction layer that transforms this 1D feature vector into 2D spatial maps. The system adaptively focuses on key subcarriers and key intervals, like we see here, for movements like, for example, push or bend, visualized in these graphs. Pose estimation module. This is this module right here. This multiformer predicts pose confidence maps, PCMs, and part affinity fields, PAFs, over multiple stages. A module called PAPM applies spatial and channel attention to refine features at each stage. This multi-stage setup progressively refines the pose prediction, correcting mistakes and enforcing anatomical plausibility. They use a non-maximum suppression and PAF-based matching algorithm using the Hungarian algorithms that solves the bipartite assignment problem for key point matching across individuals. Here they talk about the datasets they use and some comparison. So they use the self-collected dataset and the public MMFI dataset, one with 8 movements performed by 2 volunteers, and the latter, the MMFI, includes 40 volunteers with 27 actions. And models were trained using mean squared error loss on PCM and PAF. And so they start comparisons. They use the PCK, the percentage of correct key points, at 5, 10% and 20%, comparing this framework MultiFormer to state-of-the-art models like CSI Former, YSPPN, CSI Topos, and YMOS. And they report higher accuracy, especially with wrist and elbow estimation, that improved up to 64% over single-stage models. The full model has 12 million parameters, but even their lightweight versions outperforms others with fewer parameters. On MM5, MultiFormer again outperformed all baselines, including lightweight models like HPE-LI. It handled multi-person scenarios better than PAM-based approaches, which often mismatched limbs between individuals. They even tested the MultiFormer in dark environments, but this is just for show. Obviously, Wi-Fi signals don't care about dark environments. So to summarize, the MultiFormer combines a thoughtful CSI pre-processing approach, a powerful transformer-based dual-branch feature extraction, and a multi-stage attention-based pose estimation decoder. It outperforms prior state-of-the-art models in accuracy, robustness, and generalization, especially in multi-person and low visibility settings, obviously. Thank you for listening, and until next time, Regev out.